thank you for tuning in today. We're going to be doing a new unit, starting a new unit today, and we're going to talk about the Pythagorean theorem. I know that's a big word and it's really spelled strange, but it's named after a man who had a strange spelled name. Anyway, so the purpose of the Pythagorean theorem that we're going to do today, our goal, is to find the measurement of a missing side of a right triangle. So let me tell you about Mr. Pythagoras. Once upon a time, in about 500 BC, a very wise mathematician, philosopher, and teacher by the name of Pythagoras lived in ancient Greece. Little is known of his life, but being so wise, he inspired many legends. Some say that the Greek god Apollo was his father. Others say that he gleamed with supernatural brightness and that he had a golden thigh. Ew. That sounds like not fun. Okay, well, anyway, think back to those days of yore, 2,500 years ago, literally before the year 1 in the Roman calendar anyway. Believe it or not, there were people thinking about mathematics and trying to understand the world. Math is everywhere, people. Get used to it. So, let me tell you what this means to you. In a right triangle, the long side here, see right here, this long side is called the hypotenuse. Yes, another big word you're going to have to learn. And it comes from the Greek prefix hypo, meaning under, as in hypothermia, which is below normal temperature of your body, right? If you get hypothermia, you could die. As opposed to hyper, meaning over, and people who act hyper overact and act crazy and are too much energy. Okay, calm down. All right, and the tenon part, which means to stretch. So the hypotenuse is the side that stretches under the rest of the right triangle. Well, that one looks like it's on top of, so how does that work? I don't know. Just keep going. Pythagoras proved that for any right triangle, and only the right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Ooh, wow, that was a mouthful. But you'll get this in a minute. I'll show you what I mean. So we can use that Pythagorean theorem to find the lengths of one side of a right triangle if you know the lengths of the other two sides. All right, hold on. Right triangle. There it is. Okay, so we have this right triangle. See, it says so right here. That says that's a right angle, which means it's 90 degrees. And the hypotenuse is the side that is opposite that. Okay, so when you see a right triangle, consider this little box here. This is like a pointer. It's pointing straight at that hypotenuse. Okay, so that's how you find it. All right, it's always going to be the angle that is across from that 90. And it's always going to be the biggest one too. That's a good thing to know. So, the Pythagorean theorem only applies to right triangles. Only right triangles. Okay, so C is going to be our length of our hypotenuse, and A and B are our legs. They call those the legs. They're the other two sides. So the theorem is A squared plus B squared equals C squared. So keep it in alphabetical order, A, B, C, and just square them, but these two you got to add together to get that one. All right, let me show you a visual that might help those who are more visually oriented. You know how to get the area of a square. The area of a square is one side times the other side, and that gives us the area of the square. And we know that both sides are the same. So A squared is the area of this blue square here. B squared is the area of this green square here. If we add those two numbers together after we square them, we will get the same number as this one squared. So, I have a video to show you so you can really visualize what that means. So, watch this. Well, I hope you enjoyed that little video. So, in the triangle above, what is the length of side C? So we're going to try and find the length of a hypotenuse. So, we use the Pythagorean theorem, which was A squared. In this case, we're calling 6 the A. All right, A. And we're calling 8 the B. A squared plus B squared equals C squared. So we wrote this down. 6 squared plus 8 squared equals c squared. So when you put this into your calculator, you get 36. You put this one into your calculator, you get 64. That's c squared. Add them together, that's 100 equals c squared. But we don't know what c is yet when we do that. All we know is c squared is 100. Then you have to take the square root of your c squared, which is 100. Take the square root of 100, and that gives us 10. All right, let's do another one. I'll do this one with you, and I'm going to use my pen. Now we're going to see different letters in here, so we're going to figure out which ones are our A's and our B's, and the best thing to do too is to label things. So I'm looking here, X is 48, so I'm going to put this here, 48, I'm going to write it right here. So I recommend that you always do that. Y is 55, so I'm going to put that there. Now if you need to also label the A, B, C, go ahead and do that too. Now we know our 90 degree, our right triangle, or right angle is right here, so it's pointing over here to our hypotenuse. That is our C. That means the other two are A and B, and it doesn't matter the order. So we're going to take 48 squared plus 55 squared. That's going to equal W squared. Now we get out our handy dandy calculator, and we got these new ones that came. Hopefully you've got yours. And I'm going to plug in my oops, got to turn it on first. 48 squared. Ooh, that's a big number, 2304. Plus 55 squared. That's another big number, 3025. All of that equals W squared. Now I got to add those two numbers together, 3025 and 2304. That gives me 5329. Where'd my pen go? There we go, 5329. That still equals W squared. So now I've got to take the square root in order to get W. So I take that and I hit the square root button on whoa. That is only 73. And I like to look back. Does that make sense? The hypotenuse is always going to be bigger than my other two numbers. And is it? Yes, 73 is bigger than both of those. So we're good. Let's do one more problem together, and then I'm going to have you do a couple. All right, so this one's a real-life example of this teacher set up a kindergarten classroom so that there was a right triangular-shaped reading area formed by the bookshelves as shown in the picture below. So I guess there was some way for the kids to get in the middle there. That always bothered me about this problem, but I don't know. So anyway, where's our hypotenuse? Can you tell where our hypotenuse is on here? Is it A, B, or C? Well, C is what it should be, and it actually is. This is our 90-degree angle right here. We can see because of these nice little blocks. So that is our hypotenuse. Bookshelf A is 3 feet long, so this side is 3. Bookshelf B is 4 feet long, that is 4. What is the length of bookshelf C? So let's see. We've got 3 squared plus 4 squared equals C squared. 3 squared is 9. 4 squared is 16 equals C squared. If I'm moving too fast, pause, figure it out. That's 25 equals C squared. And I know that one by heart. The square root of 25 is 5. So C is 5. Okay, your turn. Give it a try. Find it. Last one. Give it a try. You can do it. Well, I hope you enjoyed this little practice. Now go on and do your try it, and let's see how well you understood what you learned.